Thank you. First, I want to say hi to my mom. Hola, mamá. Andrea, my girlfriend. Hola. And now we're going to talk about the FastAPI Internals. I'm going to be talking about some stuff there, Uvicorn, Starlette, Pydantic. I was here in the previous talk. It's really not the same. It's more deep stuff. So, yeah. I'm Marcelo Trylesinski. I maintain Uvicorn, Starlette. I work at Pydantic, so I also maintain a bit Pydantic. And yeah, that's pretty much. And what else? Yeah, I maintain those. And what's FastAPI? Oh yeah, is there anyone who don't use FastAPI here? Like never used? Never used? Okay. Cool. Yeah, the thing is, it's going to be more an intermediary kind of talk, so I'm going to be talking about deep stuff. So anyway, FastAPI is a web framework that really uses the type hint at runtime. It has two dependencies, Starlette and Pydantic, and it has been very popular lately because of how easy it is to code. The experience is very nice, has automatic documentation, data validation, and other things that are on the README. And how do I run FastAPI? I can run FastAPI with many stuff, which was also said on the previous talk. The server can be Uvicorn, which I maintain. It can also be Hypercorn, which was, this is just a bit of propaganda for the other web servers as well. So Hypercorn was created by Phil Jones. He is a maintainer of Flask as well, and he has a web framework called Quart, which is the Async ASCII compliant that tries to maintain the same compatibility as Flask. And there's Granium, that guy there. It's a web server that supports ASCII. He's Italian, so Italian. And it's written, the HTTP parsing is in Rust, right? Yeah, and it also uses UVLoop by default. But still use Uvicorn, please. So how the interactions happen. So I'm going to be talking about a specific part of this flow, but pretty much the client initiates the connection, the server accepts, and then sends data to the server, and then the server on its turn sends data to the app. On this diagram, you can imagine the client as one thing, and the server and the app as another entity. But I put it 3 steps here because we're going to focus actually on the server and the app and how they interact. And the way they interact is defined by the ASCII specification, which, asynchronous server gateway interface. Well, it's pretty much a way you define how you're going to interact from the server and the application, how they are going to communicate between each other. And this is pretty much the interface of an application in ASCII. So you need a scope, which is going to tell you information about the connection. You're going to have the receive and send, which are 2 callables. One is used to send data to the server, and the other is to receive data from the server. Yeah, that's pretty much. And what else? This is the most simple ASCII application. On the previous talk, there was an example copied from the Uvicorn documentation. But the README lacks one thing, that's the content length. We need to fix that. But this would be the full, simplest ASCII application. You have your body, you have some headers, and you are not receiving anything from the client. So I'm only sending data. This is an app, so I'm sending the data from the app to the server. And there are 2 ASCII messages being sent here, the HTTP response start and HTTP response body. There is one specific thing that happens different on the web servers. I don't know how it works in Granium, but in Hypercorn, you have the response start. But this is kind of important. But the response start is only sent in the Hypercorn. It's only sent after the response body is computed. This is a different behavior than Uvicorn, which I guess most of people use it based on the downloads. So Uvicorn actually sends the response status, like the response start first, and then you have the body being sent after. So sometimes you might see an exception on the server if you're streaming some data, for example, streaming response from FastAPI, but actually you see a 200. And then you are, how did this happen? Why is not a 500? Because we send the response headers first and the status code. So the response line is being sent first, and then you have the body being sent after. Uvicorn sends those two together. This is what happens. This is what you see is all the data that you send from the server to the application after the connection is established and well, the server receives the request line. So we get all the information about the connection. So the client, the server, address, the method, the root path, and all that information that you see there. So this is what you saw on the ASCII, what you saw on those previous slides here. This is what goes to the scope part. So this information should not change during the request response cycle, unless you use state, which I'm not going to talk about, but lifespan state is also a new thing, which is supported by Uvicorn and Granian. It's not supported by Uvicorn. So when there is a connection, you already have the scope. But then if this client sends a request, then what the server does is that it receives the request, it parses the request. Uvicorn uses HTTP tools if you install HTTP tools. Otherwise, it uses a package called H11, which Phil Jones is one of the maintainers, the guy from Uvicorn. And it sends to the application the HTTP request message. As you can see, we are only sending the body, which is, I have this. It sends the data, those bytes only. Then the app gets the HTTP request and then sends back the HTTP response start, and then the body. So I'm saying all this because this is the basics of FastAPI. Now we're going to go to FastAPI itself. We're going to talk about Starlette, Starlette and Pydantic a bit more. But this is just the basics of what's underneath, really underneath. Well, there is more underneath part, but this is the Python level goes to there. So the middleware stack. I'm going to talk about the middleware dependency and all the validation when it happens on the flow of receiving the data and where it goes back to the server, sorry, to the client. So on here you see the server, the middleware, and the application. The middleware just stands in front of between the server and the application. And the idea is that on FastAPI, you can add the middlewares in this way. So you just add middleware and custom middleware, or using the parameter middleware. Both can be used. So in this, I'm adding first the custom middleware and then another custom middleware, right? And this would be the whole flow of middlewares that you have on FastAPI. If you are not sleeping, you have the server error here that's different from, like it didn't appear on the previous slide, and you have the exception middleware as well. So those two are already in the framework itself. We have built-in middlewares. The server error, what is it? I lost it, here. The server error is, it happens when you have an exception in the application, and it just makes sure that you are sending the 500 to the client back. So you need some kind of wrapper. It could have been in the server on Uvicorn, but it doesn't happen like that. So based on the spec, we have that handling on the application. So we have the server error middleware, just make sure that we have a 500 on the client side. And we have the exception middleware. That's the one that handles the HTTP exception. You know when you put app.http exception? Thank you. So that's where you handle custom exception on your code or different status code. So you use this exception middleware that's on top of on the whole app to see which is going to be, how it's going to look the response for those status code or exception. And then the server middleware wraps everything on your application. Then there is the exception middleware. So if you have an exception on your application, it goes here. You see the application with the exception on this custom middleware, another custom middleware. Then on custom, then it goes up. If it is one of the exceptions that you saw, that you defined on the HTTP exception decorator, then it's going to be handled here, and the exception is not going to go up to the server error. Okay? So for example, if you handle, I don't know, 421, I have no idea which one is that, then you're going to send whatever you defined on this, on the decorator. If in case it's not defined here, then it pops up and you have a 500, it handles it and sends a 500. And then it sends back to the server. The server is responsible to send to the client that information. Yeah, so that was about the middleware. That's what happens. Now we're going to add the concept of routing, which different apps use different routing algorithms. But anyway, so and on Starlette, which is responsible for both middleware and the routing, there's no FastAPI in this part. It's just pure Starlette. What happens is that you have your middleware running, you have your application. Okay, so let's go back. The client sends the data, the service receives the data, it sends to the middleware, and then it passes through the application, and on the application we define to which endpoint are we going to run. So we choose the endpoint, and then it runs the endpoint. One possible problem about this, and some people have requests, is that you don't have the information about the routing on the middleware, because the routing happens after the middleware runs. So for example, if you want some information about which endpoint run, then you don't have that available on the middleware before the app runs. Yeah, that's what I have for this one. So on this one, I have two endpoints here. I'm going to ask a question, so pay attention, the ones sleeping. I have a simple FastAPI application here with two endpoints. I have the one that has on line 6, I have only a name as a path param, and on line 11, I have just the endpoint potato. If I go and if I go on my terminal and try to make a request to 8,000, suppose I'm running on that port, 8,000/potato, who thinks the endpoint on line 6 is going to run? Raise your hand. Okay. Who thinks is the one at line 11? Okay. Who doesn't think anything? Aha. Good job. So it actually runs the first one. What happens in FastAPI Starlette is it checks each path one by one. So it actually finds the first one being a match, so it goes to that one. It doesn't proceed to check the next one. So what you should do, if you want potato to work, you need to put potato on line 6 and then change to line 11. Yes?
Isn't theoretically possible to get an error because you see that they are covering the same space, like the name can hide the potato when you construct the object?
The name can hide the potato.
Yeah.
What do you mean? No, I didn't get it.
Matching of potato is already satisfied by name.
Ah, you're asking if you couldn't handle that on the web server, on the application.
Cannot you warn something?
Yes.
Yeah.
But you don't.
But I don't. So, thank you for the question. Now we have dependency injection. So here we have 3 dependencies. One is called call A, one is called call B, and one is called dependency. Okay? This is just on line 33 to 36. I'm just having this counter here called just to increase the number to see what happens. I should have deleted for this slide because it doesn't make sense if you don't see it running. But anyway, so there is a sequence of how those are running. And the sequence, so you see call A, it's calling dependency, and call B is also calling dependency, right? So what happens this is FastAPI now, it's not more Starlette. Starlette doesn't have dependency injection. So you have the app, the endpoint function, the signature, well, the handling. It's going to call the call A, and then it's going to call the dependency. This is the order, the red thing here. It gets to the dependency, it gets the result, and it comes back to call A with the result, and it goes back to the app. So it's already constructed the first part. So this part here, the A, it's already built. And now what FastAPI does, it's go to the next dependency on the signature, and it tries to see in the cache. So, oh, I forgot to say, those green lines here is that it's storing in a cache. This cache is per request. So per request response cycle, you have this. So I call B, and then B checks in the cache if the results of the dependency is there. If it is, it comes back to the application again, and that's what happens. So this is very important now. This is a concept that's not written anywhere, I think. So lucky you. I have async and sync dependencies. Async and defsync. Which one think that I should use the one on the right? Raise your hands. My hand here on this side. Who thinks we should use this one? In this case, it's just returning this string, it's not doing anything. Okay, who thinks should be on this side? Who doesn't think anything? Okay, so this is a good tip then. You should use the async def here. Why? Who knows why? No one? Yeah.
The synchronous one is running on a thread pool
Yeah.
or something, so the async one is going to be faster anyway because it's just leveraging the event loop that is asynchronous.
Yeah, that's that. Good job. So yeah, it's pretty much that. So you just should use the async def in this case because we're not processing anything. There is nothing really blocking the, well, you know, it's going to run this and it's going to send back right away to the endpoint. Otherwise, with this one, you're going to be running in a thread pool. It's just the overhead that you don't need. And also, an important information. FastAPI, if you don't change the default, it will only run 40 threads at the time. So right now, if I use this, there are 40 requests being received now, and I am running only this, I cannot receive more, well, it's going to block on the next one, okay? You can change that default. That's not as FastAPI's fault, neither Starlette. It's on any I/O that the default is set as 40. So you can change that number, and this might be one possible reason for why some code might be blocking, because you don't have enough threads. On the other hand, if you change the default to a number that's, well, pretty high, you might have other problems. But yeah, just be aware of that. Input, how am I on time? Okay. Input, output, validation, I think I need to run. So on this application, I have the input and output. This is another feature of FastAPI, in validating the input and output that is sent to the endpoint and from the endpoint. So online, this one, I have async def read item. I have the input being received, and I send back, I insert something in the database, like this input, and then it comes back, and then I validate the result with the output, which has the fields name, age, and ID. How it works, it's pretty much like that. Validates the input, runs the endpoint function, and sends back the output validation. The difference is that if there is a validation error from the input, you send back a 422, and if there is a validation error from the output, you send a 500. This might be not news. So anyway, another feature is the WebSockets. This is mainly Starlette. The only thing that the only thing that FastAPI does here more than Starlette is it reads the type hint WebSocket and it passes the WebSocket object to FastAPI. I'm just accepting doing the handshake, the WebSocket handshake, and then I'm receiving some messages on line 9 and send back the same message to the client, and then I close the connection on line 11. Handshake, and then data being sent. Yeah, so I just added this slide because I thought it would be useful. When should I use async and when should I use sync? You. It can be another person as well. It can be me.
Asynchronous, where you're doing anything that is I/O bound. I know that's a tricky question, like about the sync part. Maybe when it doesn't take a
Don't worry about it. So if it's thread IO blocking, then you should use sync. If you are running CPU bound and you are you can escape the GIL. Some packages like NumPy or Pandas, they have stuff that you can escape. Then you should use sync. If it's CPU bound but it doesn't escape the GIL, you shouldn't be running that on the web server anyway. So try to throw that to another worker or something. This is a repository that I created lately, which I give some small tips that help a lot, according to me. So FastAPI tips on Cludex. Pictures. You ready? Thank you. So Trilogfire, I work at Pydantic. We are building this new product. It's an observability tool. We also have a booth there. I am doing a demo on the screen. And my boss, the Pydantic creator, is there. So just go to talk to him. That's it. Thank you.
All right, thanks for the talk. We have a couple of questions. Keep them coming in Room Lasagna on Slido. Wait, now they're gone. Give me a second. It's not loading.
Come on, Eric.
Ah, yeah, now it's there. Okay, first question, can you use GraphQL with FastAPI?
It was you?
No.
Really?
Someone else, yeah.
Yes. It has an integration on Strawberry
you can use
side.
Strawberry, Graphene,
wait.
yes.
What one?
Graphene, Strawberry,
No, you can use
everything.
Strawberry.
Yeah, use Strawberry, guys. Next question. What are the trade-offs of having a server error middleware instead of managing errors into the server itself?
I don't know. I think hold on, calm down. I'm processing here. I don't think. I think the ASCII spec tried to match what UASCII tried to do. So that part is just handled by the application itself. I just think when they create the spec, well, that's what I think. They just didn't put that handling on the server side. They just defined to be on the application side.
All right, next up. Is it possible to use FastAPI on top of Django, basically making an async version of Django T? I think we have that question with Flask, the talk before. So
yeah, but there was more than the answer that was there. So you might try to do that if you are migrating from one framework to the other, and you might want to do that to migrate slowly to FastAPI. For Django, I'm not sure if it will be worth because of the ORM that they have and stuff. But for Flask, you can start migrating step by step. Like you put you run with Uvicorn, and then you mount the Flask into the FastAPI application. But then, so you'll be running two at the same time. Well, you'll be running Uvicorn and then creating endpoints only on FastAPI, like transitioning slowly. That's one possibility.
Right. Can you use HTTP3?
Uvicorn?
With FastAPI?
Yeah.
Yeah, okay, quick answer. When would I use Starlette directly instead of FastAPI? Good question for you, I guess.
Yeah, I mean, it was you. It was you, I knew it. So sometimes people think that what FastAPI provides is not needed for them, or they just prefer to handle some of the parts. What else can you include in this?
I'm not speaking.
That's true. So yeah, you might want to. So you might want to generate what FastAPI does, like the automatic documentation by yourself. You can add a decorator to, for example, on the Starlette endpoint, and then customize, receive some Pydantic models anyway by yourself. So
All right.
I don't think that answers it.
Two more questions. One is there any way to connect Nginx directly to an ASGI server without the need of a UWSGI middleware in the middle?
Yeah, I heard this question on the last talk. But didn't you see, like, they have that on, eh? No, yeah, but I mean, if you, I think if you Google, like, Nginx, they have on their page, they have the ASCII itself. You can do it.
But I always see tutorials and whatever, always ask to which implement we need. I don't know. It's some kind of intention, it's just all
Really, I never tried, but like if I go here, like, like there is, what is that page? Well, they might not be that popular. I think I saw it some years ago. Didn't I? Well, we can talk later. But I think there is they have a page on their docs about it, or something like that. What is it?
I think the last question is from you as well, right? Come on, just ask it in person if you're already talking.
Okay. I usually have the situation where I should return to the client HTML, not just JSON data. So if I return HTML is just computationally heavier than JSON, when the request must be built by the response class. I mean,
No.
no.
And also, then in that case, you can use Starlette because you don't have anything FastAPI related. But no,
All right, one more
because
question.
you're not. It's just.
I know if it were computationally heavier than just
No, maybe on the templating? No, I don't think so. No, I don't think so. I would say no. You might prove me wrong. No, I think no. I think the answer is no.
All right, last question in Slido. If your FastAPI is using a rate-limited backend, how can your FastAPI app know when to reject requests, for example, with the 429 status? So where you have I think it's meant you have a FastAPI application and then it accesses another service that is rate-limited. Did I get that right? And then how do you know when to reject requests?
So you have your FastAPI, you have an endpoint, and then you call some other service, and then it returns.
Maybe someone wants
And
to
you
clarify?
want to
Yeah, the other service does not return an error, but you know that from your app you can only call, you have to like know how many requests in total are accessing that, so that you can only have like 20 open connections in the backend. So you have to count like, you have an endpoint,
Yeah, I got it.
like potato,
Yeah.
and I'm calling potato.
You get it.
I'm calling 20 potatoes, but I can only serve 10 potatoes.
Yeah.
So like if somebody else has asked for the 11th potato, and I've not served the 10 ones, my FastAPI should not ask for another potato. How do I manage that state properly?
So you don't want it to block
I
or
don't
something?
want it to ask for another potato because I know this thing is not going to get me one. Because I know I have 10 open requests for potatoes.
Yeah.
And until I get those 10 potatoes, it's pointless to ask. And if I ask it,
Yeah.
then it will send me a potato too late later. So I will sit with the potato.
And then you need to call it again later?
Because there's like in the production, there's a queue, like a queue with jobs. And I don't want to put too many jobs in the queue.
I don't know. No, I mean, so I have two options here. Either I send a request and I do something after, which you don't want, it looks like, but maybe.
Basically, I was thinking of like, can I have like a global state where I count how many potato requests are? Because I only can look at the request state, but I don't know.
Well, you can put the. Oops, I'm so sorry about that. So you can put the client on the lifespan state. So you have the client there, and then you can check the number of connections that are already on the client.
Okay.
So you can do that. You have the number of connections on the. I mean, if you are talking about HTTPX, for example, you can have that information, and then you yeah.
Yeah, thanks.
We can talk later as well.
Great. Any more questions in the room? I'm happy to. Yeah.
I think sometimes someone recommended me to run on production servers a combination of, I think, Unicorn plus Uvicorn to spawn multiple servers, and then in every instance you have a worker with a different like ASD server serving the whole thing. Is that still the recommended way to scale FastAPI apps? What should I do to scale the app?
It was never my recommendation. So what's written in the documentation is a way. You use Unicorn to manage the Uvicorn processes. So when one Uvicorn process dies, it does the survival thing and it gets one back again, right? But then nowadays people like Kubernetes and stuff, and it's simple to treat the unit as only having one Uvicorn worker, and then put the resources according to this. So you have one Uvicorn, you put the resources there according to this.
Then you scale the pods.
Yes. Yeah, but also this is new information. I'm waiting for him to leave, so I say it. If you have the Unicorn, like right now I'm deprecating the Uvicorn worker. So with Unicorn, you'll have there's another package that's been created called Uvicorn worker. So you can do that. But Uvicorn itself is going to have the process manager on the next release. So if you still use Unicorn with Uvicorn, you can remove Unicorn on the next release.
All right, any more questions? We have some time left in the slot because this was a shorter talk. And if you have any questions, just raise your hand. All right, doesn't seem to be that way. Then thanks, Marcelo, again.